everyone, welcome back to my YouTube channel. So today in this video we'll be discussing about the combination of resistors. This topic will be basically for class 10 students, but for class 12 students also this will be a revision where you can solve numericals based on this equations and all. Alright, so let's start the video. So we know that in a circuit we can connect resistors either in series or in parallel, or we can have series and parallel both depending on our need. But basically we will discuss only about the series combination and the parallel combination, right? So here in the circuit you can see I have not in the circuit, here in the diagram you can see I have taken two resistors, and in the first case the two resistors R1 and R2 they are connected in series, and in the second case the two resistors are connected in parallel. Now you have to understand what is a series combination and what we call as the parallel combination. Series combination is one in which the resistors are connected end to end. That means one end of the first resistor is connected to the other end of the second resistor, and it is not a closed one. So here you can see that the resistor R1 is connected with the resistor R2 at this particular point, but the other end is open. So whenever two resistors are connected end to end, we call it as the series combination. But here in the second picture you can see that R1 and R2, both the ends are connected together, right? And it is a closed one. Okay, so whenever we have two resistors connected in such a way that both the ends are connected together, then we call it as the parallel. Series means end to end, and parallel both the ends has to be closed or both the ends has to be connected. So we will derive equation for series combination and parallel combination of resistors. Alright, so let's first discuss about the series combination. So here in the circuit you can see I have taken three resistors. So this is the symbol for the resistor. So we have three resistors R1, R2 and R3, and they are connected in series because they are connected end to end. So this is series combination. So R1, R2 and R3 are the three resistors which is connected in series across a battery or a cell whose voltage is V. And this is the switch or the key, and we know that whenever the key is closed, the circuit will be complete and current will flow from positive end of the battery towards the negative end. Now the current flowing in this circuit is I. Now here what you have to remember is, as the path is same in which the current can flow, there is only one single path, so the current through all the resistors, that is R1, R2 and R3, will remain same. The current will not be distributed because there is only one path or one way in which the current can flow. So this I current flows through R1, R2 as well as R3. But since they are connected in series, this potential of the battery will be divided into three parts. So the voltage or the potential drop across R1 will be V1, potential across the resistance R2 will be V2, and potential across R3 will be V3. So while deriving this equation, what we will simply do is we will use Ohm's law, which is V is equals to IR. We will find out the value of V1, V2 and V3, and we will add V1, V2 and V3 to get the resultant or the total voltage V. Alright, so let's start this derivation. Now from Ohm's law, so you can start with this equation. So from Ohm's law, what do we have is, we know that V is equals to IR, that is current into resistance. You can take this as equation number 1. Now if V is equals to IR, then we will find out the value of V1, V2 and V3. And if we add V1, V2 and V3, we should get back the total voltage or potential V. Alright. So now for the first resistor, resistance is R1, potential is V1, the current flowing is I. So if you follow the same equation, V is equals to IR, then here for the first resistance, that is resistance R1, this same equation can be written as V1 is equals to I times R1. Now as I said, current through R1, R2 and R3 will be same. So you don't have to write I1, I2 and I3 because current will remain same. But the resistances is different, R1, R2, R3, and potential is different, V1, V2 and V3. So V is equals to IR from Ohm's law. So for resistance R1, the same equation becomes V1 equals to I times R1. Similarly, you will find out for resistance R2, that is the second resistance that we have connected in series. So for resistance R2, the same equation can be written as V2 is equals to IR2. You can write this as equation number 3. And for the third resistance, that is R3, you can write for resistance R3, the same equation can be written as V3 is equals to I times R3. So when we do the series combination, you can see the voltage is different. Alright, so we need to find the value of these voltages. Okay, so using Ohm's law, we have first equation. For resistance R1, we got V1 equals to IR1. For resistance R2, we got V2 equals to IR2. And for resistance R3, we got V3 equals to IR3. Now, since this V has been divided into V1, V2 and V3, so when you add V1, V2 and V3, you should get back V. Alright, so we can write total potential will be V is equals to V1 plus V2 plus V3. Okay, now we will replace the value of V, V1, V2 and V3 from equation 1, 2, 3 and 4. So you can write here V from equation 1 is your I times R, V1 is your I times R1, V2 is your I times R2 and V3 is your I times R3. So from where we have used these values, you can write here using equations 1, 2, 3 and 4. So we have replaced the values of V, V1, V2 and V3 here. Alright. So now on the right hand side, what we can do is you can take out I common, I is same, so you can take out I. Then we have R1 plus R2 plus R3. So you can cancel I and I. So you'll get the final equation as R is equals to R1 plus R2 plus R3. So whenever you have resistors in series, here I have taken 3 resistors in series. So its equivalent resistance will be given by R is equals to R1 plus R2 plus R3. So this is called as the equivalent resistance. Now few things you have to note. This derivation is very simple. Few things you have to note here is whenever the resistances are connected in series, then first of all current will be same through all the resistors. Okay, potential will be different across each resistor. Now the third thing that you have to remember is whatever equivalent resistance that we get, alright, that the value of this equivalent resistance will be always greater than the greatest value that is given. For example, if I have these resistors, R1 is equals to 1 ohm, R2 is equals to 2 ohm and R3 is equals to 3 ohm, let's say. Now the equivalent of these 3 resistors, according to the formula, we can write R is equals to R1 plus R2 plus R3. So if you put the value, this will be 1 plus 2 plus 3, which will be equal to 6 ohm. That means the resultant or equivalent resistance that we are getting when we connect R1, R2 and R3 in series is 6 ohm. And you can see that this value 6 ohm is greater than the greatest value which is supplied or which is provided to us. So among 3 resistors, this R3 has the highest value, which is 3 ohm. And the equivalent that we are getting is 6 ohm. Alright, so therefore we can say that the resistance of the equivalent will be greater than the greatest value that is given. And you can see that the resistance will always increase when the resistors are connected in series. The value of resistance will always increase. So this is our series combination. Now let's discuss about the parallel combination. Okay, so here we are discussing about the parallel combination. So in the circuit you can see we have 3 resistors, R1, R2 and R3, and they are connected in parallel. You can see that all the ends are connected together. Okay, so these 3 resistors are connected together on both the sides. So these 3 are in parallel combination. So these 3 resistors are connected across a battery whose voltage is V, and this is the key or the switch, and as soon as the key is closed, current I starts flowing from positive side to the negative side. Now here, unlike series combination, as the current reaches this point, there will be three different directions in which the current can flow. Alright, so depending on the value of resistances, the current will distribute itself into three different parts. So we will say that I1 will be the current across the resistance R1, I2 will be current across R2, and I3 will be current across I3. So this current I has been divided into three parts, I1, I2 and I3. Now as this current reaches this point again, these three currents will combine together and give us the total current I, because the current in the circuit will always remain same. So here the current will be split into three parts. Here the three parts again meets and give us the total current I. Alright, so here we need to find the value of I1, I2 and I3. So here again we will be using the Ohm's law. So we know from Ohm's law we have V is equals to IR. Now here, since we need to find the value of I1, I2 and I3, we will write this equation as I is equals to V divided by R. Simply cross multiply R, it goes to the denominator, it becomes V divided by R equals to I. Or we can write I equals to V divided by R. Now in parallel combination, current will be different. But since they are connected together at their ends, the potential will always remain same. So here we will not have V1, V2 and V3, but we will have I1, I2 and I3. So we are finding the value of I1, I2 and I3. Alright. Now, if I is equals to V by R, then the value of current I1 will be equal to V divided by R1. Since for resistance R1, the current flowing is I1 and the voltage is, or the potential difference is V. Therefore, I1 is equals to V by R1. Similarly, I2 can be written as V divided by R2. Let this be equation number 3. So for this resistance R2, you can see the current is I2 and the potential is V. So I2 equals to V by R2, and for I3, we can write this as V divided by R3. Resistance R3, the current flowing is I3 and the voltage or potential is V. So we have obtained the value of I1, I2 and I3. So when we add I1, I2 and I3, we should get back the total current, because here at this point, this current has been divided into three parts. And here the three currents will combine again and give us the same current I. So we can write the total current I is nothing but the sum of I1, I2 and I3. So we'll replace the values of I1, I2 and I3 from equation 1, 2, 3 and 4. So you can write here I is nothing but it is V divided by R. I1 is nothing but it is V divided by R1. I2 is nothing but it is V divided by R2, and I3 is nothing but V divided by R3. So we have used equations 1, 2, 3 and 4. So we have just replaced the values. Now what we can do in the right hand side, we can take out V common. So if we take out V common, we will have 1 divided by R1 plus 1 divided by R2 plus 1 divided by R3. And here we can cancel V and V. So your final equivalent resistance will be given by, or the equation will be 1 by R equals to 1 by R1 plus 1 by R2 plus 1 by R3. So when three resistors are connected in parallel, then its equivalent resistance can be calculated using this equation, which is 1 by R is equals to 1 by R1 plus 1 by R2 plus 1 by R3. So this is the formula for calculating the equivalent resistance. Alright, so this derivation is also simple. You can see the steps. Now, few things that you have to remember here when resistors are connected in parallel. And remember, these equations are also important for doing the numericals. Okay, not only the final equation, but these equations are also important. Now, few things that you have to remember when the resistors are connected in parallel is, number one, resistors when connected in parallel, they will have the same potential. Okay, but the current through them will be different, and it depends on the value of their resistance. And the third thing that you have to remember is that whenever resistors are connected in parallel, then the value of equivalent resistance will be always lesser than the least value. Alright, so let me explain that with the example. So let's take some value for the resistances. So let me take two resistors. R1 is equals to 2 ohm and R2 is equals to 4 ohm. Let's say they are connected in parallel. Then according to the formula, the equivalent resistance can be calculated using this formula. 1 by R is equals to 1 by R1 plus 1 by R2. Or 1 by R, the value of R1 is 2 and the value of R2 is 4. Now take the LCM. So you will get 1 by R is equals to, the LCM will be 4. So this will be 2 times plus 1. So this will become 3 divided by 4. And students, just leave it here. Okay. What we have to calculate is the value of R. And what we have obtained till now is 1 divided by R. So the final step will be here to cross multiply or to take the reciprocal. So if you take R, then this becomes 4 divided by 3. So if you divide 4 divided by 3, then it will give you 1.33 and it will go on. That means the equivalent resistance, its value will be 1.33. And in the given you can see among the two values, the lesser value is 2 ohm. So what I meant to say here was, whenever resistances are connected in parallel, the equivalent resistance will be always lesser than the least value. Whatever least value is given, equivalent resistance will be lesser than that. Okay, and when the resistors are connected in parallel, the resistance will always decrease. Okay, so in series combination, resistance will increase. In parallel combination, resistance will always decrease. So this was a simple derivation based on series combination and parallel combination. And numericals are important from this section. So we'll discuss numerical in the next videos. Alright, so do check the series combination and the parallel combination. Do like, share and subscribe my videos, and thank you. I'll see you in the next video.